Well, hello there. Welcome back to my stream for another day. Um, yeah, so pretty uneventful. What's going on today? It is the seventh challenge, so we're 1 week in, which is kind of exciting. Before I started the stream today, I tried to set up a little bit of a script to automatically download each the input for the day. So I wanted to write some sort of function where I could just go input.get day 7 or something, and I'll just automatically get the data. But JavaScript HTTPS requests are pretty hard to get your head around. I shouldn't say it like that because it's not true. I think with especially with async await, it's pretty easy. It's just that I was let's say too lazy to look up how to properly do asynchronous requests, and like it is a little bit of a pain. You got callbacks and things like that. I think with async await you can get away without a lot of that stuff, but yeah, I didn't really get to use those things much when I was still coding professionally, and I need to sit down and learn it. And so I couldn't get it done in time before the stream, so I decided to put that off. So I might have that sometime later in the future. The other thing I kind of wanted to do, really, before the stream was that I noticed that a couple of the inputs, for example, day 6's input, right, uses this batch file idea where you have like multiple lines is one element, and then it gets separated by a new line, then you have more multiple lines for a new element. And this pattern has happened more than once, right? I think day 4, yeah, day 4 also had this style where multiple lines of input was one record, and it was separated by new lines again. And so what would make sense is to write a function to help parse this kind of input to save a little bit of time. Yeah, if you watch the other I guess episodes, not the other days, I guess, I'm not sure what to call it. I did spend a bit of time writing the parsing code for that. And you know what, since I have 2 minutes, I may as well do that right now, just in case. Function split input, just in case I need that. We'll call it rows. How would you do this? Elements, let's say. So I'm just going to write a short function to parse that sort of input, just in case we might need it. If we don't, I can save this for next time. I have 1.5 minutes to finish writing this. I don't know if I can do it. If, let's see, rows I is blank line, then push next. Next is something new. Continue. Otherwise, next dot push rows I. Yeah, I think that's pretty much it. So that should, yeah, well, we can give that a go. We can read last week's input and see what happens. What do we get? We get an error. Oops. That should be a let. Yeah, so that actually groups stuff up for us pretty well. So we just have a little function here, just in case we might need it. To help us split the input. So we have 10 seconds to go. I'm excited. Let's see what happens. Here we go. Let's kick things off. So we've landed. Luggage processing, for example, consider the following rules. These rules specify the required contents for 9 bag types. In this example, every faded blue bag. How many bag colors can eventually contain at least one shiny gold bag? Okay, so is our input these rules? Oh, okay, so we'll have to do some interesting reading. Okay, the specify required contents for 9 bag types. Light red bags contain. Okay, so it looks like every bag name can have 2 things. So this looks like some kind of graph problem, but we just need to do a little bit of fancy parsing. So we definitely don't need this kind of split input thing. So I'm just going to get rid of it because it's easier to write again if we need it. Okay. What's going on? Unextracted string. Oh, I forgot to put a comma at the end. Okay. So consider this. Light red bags contain 1 bright white bag and 2 muted yellow bags. Muted yellow bags contain 2 shiny gold bags and 9 faded blue bags. Faded blue bags contain no other bags. Right, some kind of like Matryoshka doll thing. I have a shiny gold bag. If I wanted to carry it in at least 1 other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least 1 shiny gold bag? Yeah, so it is a graph problem. In the above rules, for example, a bright white bag can contain a shiny gold bag directly. A muted yellow bag can contain that. Dark orange can contain those, which contain that and that. So in this color, at least 4 bags. Yeah, so it is a thing. Okay, so we need some kind of parsing thing. So we'll do this 1 row at a time, just because at least this is quite straightforward. I might actually parse this with regex, which is a bad idea for parsing. Don't use regex to parse. But when you're doing a timed challenge, we can make allowances for breaking the rules. Okay, so we know colors are 2 words with a space. So we'll do that. Bags contain, and then we want the rest of the row, the rest of the line. Yeah, we want the rest of it because we need to do some extra processing on that. Dot match, I'm guessing. It's not a function. Okay. MD. Maybe we can do something like this. Okay. A dot. What do we have available? A dot compile test multi-line sticky exec. Exec looks like the function we want. A dot exec. Yeah, cool. Console.log a. What do we have? Groups undefined. Wait, here we go. Look, 1 and 2. Okay, 1 and 2 are good. Okay. Okay, so then we have 1 and 2 are the 2 things we need, right? Yeah, cool. So 1 is the bag type. Okay, so function, we're going to put this in a function because we need it. Parse, what do we call it? Rule. Our regex, our first layer of regex is this. Const So const r1, we'll call it dot exec rule. So r11 is the bag type, so const bag type is r11. Const contains is r12. And we're going to split that on comma space. I'm going to guess that some of these have multiple. Yeah, they have multiple. Okay. Cool. So now we're going to need to parse all the individual ones, right? Cool. We're going to need to parse these individual ones. Two bright gold bags. Cool. So to parse that, we're going to say for const contain of contains. I know I have great variable names. Equals. Let's see. We have numeric, and I'm going to guess. We don't actually care about the number in front of these things at the moment, do we? No, we don't, because this is the level 1 challenge. Yeah. But I'm going to make this multiple numbers just in case. Number, and then we're going to have this thing. Yeah, when we can ignore the rest. Exec that on contain. And then we're going to say const num equals r21 and const color. Let's call this color. Outer color. I'll call this inner color. Was r22. We're going to need to store that somewhere, right? So const inner equals empty inner dot push. Actually, we're not going to push. We're not going to push. We're going to do this. Inner color equals num. So we're going to do this. Let's see what that tells us. Yes. Okay. So you see right here at the bottom we have a an object of the bags it contains with the number that it contains, and we're going to parse this because we're going to need to operate on it later on, I bet. So it's an actual number, like you can see at the bottom now of the screen, not a string. So we're going to return. What are we going to return? We're going to return. We'll return it separately because may as well. Color and inner like this. Cool, so we have that. So what we're going to do now is convert this into a giant object. So let rules equals an empty object for rule of input color and inner equals parse rules color equals inner, and that should be our rules parsed. Can't read property 1 of null. Ah, right, some of them might say no other bags, right? Yes, some of them say no other bags. So how would we know that? R2 of null. Okay, so if R2 is null, then that's it. If R2 is null, then we're done. Cool. All right. So we have all the rules. So what do we want? Oh, this is a graph, right? So we want to find all the bags that can contain shiny gold bags, right? Like one of these should be able to contain shiny gold bags. If I search in here, shiny, I can't even just look for shiny gold. Yeah, so some of these bags will be able to contain shiny gold bags. Then we just have to walk all the way up the tree to find all the ones that can still contain shiny gold bags. So shiny gold is what we're looking for. Okay, target is shiny gold. Let's go. Let's go. Rules. So for const key of, so I'm guessing this is an A-directed graph as well, right? If it isn't, it's gonna be it'll be infinite. Oh, maybe it won't. Huh, interesting. I wonder if there's loops in here. Okay, so for every let's say color in rules, if color target isn't null, so if that exists, okay, yeah, so we need a push, right? Okay, how do we do this? Const q, const, and const found, and we're going to make that a set. Okay, so found color equals true, q dot push color. Yeah, okay. So if not found color, then found and that, right? Because we don't want to keep reprocessing ones that we've already processed. So only if we haven't already processed this color that we've found, we want to chuck in the queue to process. So then here we want to say, yeah, okay. So the queue to start with is shiny gold. That's how we do this. The queue starts with shiny gold. So while queue.length is greater than 0, we go const target equals queue.pop. Okay. Okay, this is something along these lines is right. I just need to debug it. Yeah, okay, so that gives it to us, and Q should now be one less. Yep. So for const color in rules, if what color? What if rules color target isn't null? That's better. Cool. All right. Something like this should be right. If it's not, then I'll debug it. But apparently we can have 287. Yes. Okay. So, all right. Let's see the second half. Let's see if we have a chance to get this thing. Because Rick is on bags, you need to buy consider contain 0 bags. So a shiny gold bag must contain. How many individual bags are required inside of your shiny gold bag? Okay, so this time it's a bit easier. We're going the other way around, right? This time we start with shiny gold bag and we count how many bags we need inside the shiny gold bag. So we start with shiny gold. So we probably still need something like this. We start with shiny gold. Count equals 0. Right, we start with the shiny gold bag. We go rules while q.length is greater than 0. This is the same as before. We want to say, so again, we're assuming this graph is adirectional. Otherwise, we're going to get into an infinite loop somewhere. we're going to say rules next. So this is the array that has the things it contains, right? Yeah, okay. So for const inner in that q.push inner count plus equals rules next inner. $168. Oh, I got it close. Okay, I got it wrong. Ah, you gotta multiply them. That's kind of silly, but yeah. All right, yeah. So, because if my bag contains 2 bags inside it, 2 of the same bag, those 2 bags inside it now contain, so however many bags those bags contain, I have to multiply it by 2, right? And so this is actually some kind of recursive thing. Yeah. Okay, I need a function, bag count of a color, and this is going to return. It's going to return rules color object.values of rules color const bags equals rules color yeah, we'll just do a reduce here. Return that dot reduce a plus n, and we start at 0. That looks like I have a bad set of brackets. So we can test this kind of quick. I can just go bag count. The color we see here is mirrored blue, and that should give me 8. Yeah, 8. Good. Okay. So I kind of do need this. So there's that, but no, that's not true. Yeah, okay. So this has to be a recursive function, right? If bag count, okay. Yeah, this is a recursive function. So let's start with this. Const bag, okay, yeah. We'll have to break this down. Const bags equals that, right? So that gives me the length of the maybe I need keys here. All right. Yeah. Okay. So if there are no more if this bag contains no more bags, right? If this bag contains no more bags, then we return 0. Right? This bag contains no more bags. We return 0 because we're counting the number of bags inside this bag. Yeah. Okay. Otherwise, what we want to return is we want to go for every bag inside here. So these are all the keys. For each bag inside here, we want to return the number of this bag times the number of bags inside that bag. Yeah. That should be right. And then we can reduce that. And that is going to be a recursive function, but it should be correct. And hopefully it doesn't, it returns. I think q was not defined. 0. 0 is not the number I want. Object.keys rules color. Do what? Contain, yeah. So object.keys of that should be, wait a second, what is going on here? That length is not 0. So there's something gone wrong with this, I think. That recursion should work. I don't see why it doesn't. I don't see why that recursion doesn't work. Oh, I'm really baffled right now. Rules, color, C. Wait a second, what? Oh, well, of course it equals 0. What the? My equation was wrong. My equation was completely wrong. What the? Hang on, if one bag contains 3 bags, right? It's got 3 bags. And if each of those bags contains 0 bags, then I've still got 3 bags. Right? But if I have 2 bags that contain 1 bag, if I have 2 bags where each bag contains 3 bags, let's say, then I have, hang on, I'm doing this wrong somewhere. If one bag contains B, C, and D, if B contains E and F, and C contains, and I have 2 Bs, and C contains nothing, and D contains 1 bag, then how many bags do I have? I have 10 bags here, and then I have another 4 bags from this, which is 2 times 2. Then I have 3 times 0, and I have 5, which is 5 times 1, right? So I need to return 10 bags plus whatever this number is. Okay, so I need to return I need to return this plus object.values rules color dot reduce by the same thing. There's probably a better, cleaner way to do this, but I just want to get this right now. 48,160 bags. And I got it right. 700th place. Oh, these nested problems are quite tricky. All right, so let's do a little quick review of what that was all about. Because, yeah, there was a lot of weird stuff going on there. I'm kind of happy that this ended up being quite straightforward, though. So the first half of the question asked, how many different bags could contain a shiny gold bag? Right? And it's an interesting question, right? If you have A can contain B, C, and D, B can contain E and F, and then F can contain the shiny gold bag. But let's say G can also contain, let's say D can also contain a shiny gold bag, and C contains G and H can contain a shiny gold bag, right? Then H can contain a shiny gold bag, but then because C has an H, then so can C, right? C can contain a shiny gold bag. And then D can contain a shiny gold bag, F can contain a shiny gold bag, B can contain a shiny gold bag because it contains an F, and A can contain a shiny gold bag because it contains everything. And so what this algorithm does here is we start with a queue of shiny gold bags. Maybe we start from here. How would you find every bag that can contain a shiny gold bag? What did we do just then, right? We basically looked at the first level, which bags could contain a shiny gold bag, right? And that's D, F, and H. And then, but that's not enough, right? Now we need to find all the bags that can contain D, F, and H. And so then that adds us, so all the bags that can contain D is A. All the bags that contain F is B, and all the bags that contain H is C. We might want like something here, so that's unrelated. And so how did we do that, right? So we basically looked through this list once, and we said, we're looking for target. Target is shiny gold bag. And we found all the ones that could do it, that could contain it. So you have D, F, and H. And what we do is we basically turn this into a queue. We put D, F, and H into here as a queue. Now that we've found shiny gold, we remove it from the queue. Now we look for D. All the bags that can contain D, we find it, A, we put the A in here, we check the A at the end of the queue, and we remove D. Now we look for all the bags that contain F, that's B, B, remove that and put B at the end of the queue. Then we look for H, C can contain H, so we put C at the end of the queue. Then we look for A. Which bags can contain A? No bags can contain A, so we just remove it from the queue. B, same story, C, same story. And then once the queue is empty, we've basically checked every possible bag that could contain a shiny gold bag, or a bag that can contain a shiny gold bag that contains a shiny gold bag. And we're done. And so that's what this algorithm here does. We start with shiny gold in the queue. This is a list of all the bags we've found. And then to prevent ourselves from getting into a loop, we basically say, well, we start here. We start with target bag we're looking for, is just the next item in the queue. And then here we use this to stop ourselves from getting into a loop. So we say if the bag, we look through every single rule. And this is a slow way to do this, but we look through every single, we look through all the rules, and we find all the bags that can contain the bag we're looking for, right? If it contains it, then once you index into it, it is not null, it exists. If we find it, then we want to add it to this found set that we have. But we want to have a little, what do you call this? Condition, a guard, right? If we've already found this bag, if we've already checked this before, we don't want to check it again because we've already found all the bags that contain it in that sort of branch. right? And we just add so we do what we said. We add it to the found list, and we push it into the queue. And that's exactly what we did. And that's how we got that first part of the question. And the second part of the question is going the other way in the graph. This is looking up the graph, right? This is looking for all the bags that can contain shiny gold bags. The second part of the question was looking down the graph and looking for all the bags that shiny gold bags contain. And you saw me kind of working it out earlier with the numbers, right? You want to, because one bag can contain 3 bags of the same kind. So however many bags that bag contains, we have to multiply it by 3 in order to get the actual total amount of bags, right? That's why our first number was 100 and something. It was too low, way too low, because we forgot to multiply the bags by the actual count, the actual number of the bags inside the bags. And so this sort of problem was done really well with a recursive algorithm. Now this is an unoptimizable recursive algorithm. This is an algorithm that you can't optimize by what's called tail call recursion, which I won't get into. But basically, if you write code like this and put it into production, you're a naughty programmer, and you should rethink. You should be scolded by your teammates during your code review. But like I said, for time challenges, this sort of code, as long as it works and I get my answer within a short amount of time, I'm happy. Do as I say, not as I do. So the way recursive algorithms work is you need to start with a base condition. So this is the base case. If this bag contains no more bags, that means there are no bags in this branch, and we return 0. But if this bag contains bags, then how do we know how many bags? Then we just want to return how many bags we contain. And how many bags we contain is the number of the bag of each type of bag is the number of bags that each of the bags we contain times the number of that bag we have, which is what we have here, right? It's the number of this first bit is the number of C is this is a loop, right? C is the type of the bag, is each of the types of the bags we contain. This expression here is the number of that type of bag, and we just call ourselves, right? We call bag count, pass it the next type of bag, which will then recursively get how many bags that bag contains, multiply it by the number of bags we contain, and then here at the end we just need to add in the actual number of bags we contain as well. If I contain a bag that contains 2 bags, I'm actually holding 3 bags, because I'm holding 1 bag that then contains 2 bags. So it's 2 plus 1. And that's why there's this plus here. This is the number of bags I contain plus the number of bags that those bags contain. And yeah, that was this extra bit was what I was missing, which was what I was trying to work out earlier in the video. So that was a really cool challenge. I kind of liked it. Graph challenges, I think, are always really fun. They are a little bit tricky, especially if you haven't brushed up on your graph theory. But generally, these sorts of things work like this. And yeah, so great challenge. I enjoyed it. And that wraps up 1 week's worth of challenges. So we are what, we're like 18 days to Christmas now. So look forward to the rest of the challenges, and I will see you next week.